Okay, guys, so let's do this. Suppose the length of this side is A, right? And suppose the length of this side is B. And the length of the hypotenuse, let's make it C. So we are saying we can draw squares on each of the sides. So the square that you draw here, can you give me the area of that square? What is the area of this square that I've drawn here? If this side is A, remember it's a square, and a square has all sides equal, right? So if this side of the triangle is A, then it means the square that we are drawing there measures A units by A units. So what is the area of that square now? So that is A times A, which is A squared, right? So A times A is A squared. Then this other side has a length of B. So if this is B, then I'm going to draw a square. And the sides of this square should be equal to B. So if that is B, then this is B, then this is B, and then that is B. So what is the area of this square here? That will be B squared, which is B times B. So it's B squared. Now the other one, the length of that side is C. So the square that I'm going to draw there should be a square measuring C by C. So it's a square measuring C by C. I don't have enough space there. So every side is equal to C. So what is the area of that big square there? Do you see that that will be C squared? Now I need somebody to give me the equation according to the theorem of Pythagoras. The equation that connects A squared to B squared to C squared. A squared plus B squared should be equal to C squared, right? Okay, so that is what we mean. Now you need to understand where the A squared is coming from. Obviously, this is the square that we can make or produce from the side of the triangle that measures A. B squared is the area of the square that can be drawn using the side, that side of the triangle. And C squared is that one. So A squared plus B squared is equal to C squared. This here is called the Theorem of Pythagoras. Okay. Just like we were answering some questions and we were giving reasons, whenever you find yourself using this formula here, your reason will be Pythagoras. You'll simply say Pythagoras because we will be using this. So now look at an example. Suppose, for instance, that this is a right-angled triangle, and maybe this here is 3 centimeters, and that there is 4 centimeters. Can we find the third side? Yes. Right. Let's find the third side. Matume? So yes, 3 squared plus 4 squared is equal to x squared. What is the reason for that? Pythagoras, right? And you can just write it in short as Pythag or Pyth, whatever. Can you not say top for theorem of Pythagoras? No, say Pythagoras, it's okay. Say Pythagoras. Okay. Then you can simplify this. So this is 9 plus 16 is equal to x squared, which means 25 is equal to x squared. And now to get x, we take the square root both sides. So the square root of 25 will be 5. And the square root of x squared is equal to x. Can you copy that example down? You can find that same question, I think, in your worksheet. What about this one here? I want this to be 6 centimeters, and I want this one to be 8 centimeters, and I want to call that one y. And you are given here that the triangle is right-angled. Right, so please find y. It's a y. So 8 squared plus 6 squared is equal to y. Okay, that is meant to be y squared, right? And remember, guys, if you want, you can say y squared. You can start with y. So you can say y squared is equal to 6 squared plus 8 squared. That is exactly the same thing. Okay, so if you say this, then you need to give me a reason. What is the reason for this one?
Pythagoras.
Pythagoras. Okay, so the reason is Pythagoras. Always give us the reason. Then you can simplify that. 8 squared is 64, and 6 squared is 36. So all that is equal to y squared. And that gives us 100 is equal to y squared. Then if you take the square root, that should give us y equal to 10. If you want units, the diagram says this is in centimeters, so y should be equal to 10 centimeters. Just one last example. At times you get something like this. Now there are two triangles here. Suppose, for instance, that this one here is 3, and this one here is 5. And we want to find x, given that this one here is 16. Tell me, do you see a method that you can use for that? The clue is we can use Pythagoras theorem. But how? How many sides should be known in order for you to get a third side using Pythagoras theorem? 2, right? So we need 2 sides. If you look at the examples that we worked out, like the previous one here, we are given 2 sides, and we can use the 2 sides to find the third side if our triangle is right angled. So there has to be 90 degrees. In this case, we are given 2 right angled triangles. We are trying to find x, but it looks like in that triangle we only know one side, which is 16. We don't know the other side. So how do we use Pythagoras when we don't know the second side? What do you think we can do here? Which side is missing? Yes, Jenna?
So you find out that BC using the other triangle.
Yes, so we need to find out BC using the other triangle. So not everything will be given like that. So in this particular case, we need to find BC first. We are given enough information to find BC. So first of all, find BC. Then when you know BC, you can use it now to find x. Right, can you give me the equation to find BC? Give me the equation. Yes.
So I said 5 squared minus 3 squared equals BC.
That is correct. You said 5 squared minus 3 squared is equal to BC squared. Okay. But in case somebody does not get it, remember 5 centimeters, that length AC will be your hypotenuse because it is opposite your 90 degrees. So we know that BC should be less than 5, right? So BC is one of the 2 shorter sides. So when you take the 2 shorter sides and you square them and you add up the answers, you should get the square of the longest side. So what you can say initially is the BC, if you square it and you add 3 squared, we should get 5 squared. And the reason is Pythagoras theorem. Right. That is where she is getting BC squared is equal to 5 squared minus 3 squared, because we can now move our terms. Right, now if you simplify, 5 squared is 25, 3 squared is 9. So this means BC squared is equal to 16. So guys, if BC squared is 16, to find B we need to take the square root of 16. So we agree that BC will be equal to 4. Yes.
Don't you subtract it when you take it over?
Yes, we do subtract it. We have done it here. Remember, you see this line here. We are subtracting there already. Okay. So initially, I just took the two shorter sides, squared them, and added them together. And I'm saying they will give me the longest side. But what it means is exactly what follows there. BC squared is equal to 5 squared minus 3 squared. Please do not forget the reason, Pythagoras. So we now know that BC is 4. So we can go there and put 4. And now, how do we get x? I'll work it out here. How do we get x? Yes, Leola? That is correct. 16 squared minus 4 squared is equal to x squared. You can start there if you understand it, okay? But if you want, you can start right from the beginning and say the two shorter sides squared and added. Like you can say 4 squared plus x squared should give us 16 squared. And that means exactly what he says here. That means x squared will be equal to 16 squared, subtract 4 squared. Right, so your reason is still Pythagoras. Okay, so that is still Pythagoras. Why are we minusing? Do you understand what we mean by 4 squared plus, why we have 4 squared plus x squared? Yeah, do you see it's 4 squared plus x squared, right? So I'm moving the 4 squared to the other side. Okay, 4 squared is moving to the other side, so it is positive on the left. So when I take it to the other side, it will become negative. Okay? Right. You can work that one out for me. What is 16 squared? 256. Subtract 16. What is 4 squared? 16. So this gives us x squared is equal to, what is 256 minus 16? Is it 240? 240. And now this is where we will allow you to bring a calculator. Remember, at times we are nice. We allow you to use a calculator, right?
Yes, sir.
So x will be the square root of 240. Okay, you can put that in your calculator and maybe write your answer correct to 1 decimal place.
15,49.
Is it 15,49?
Yes. Yeah.
To 1 decimal place, what is it?
15,5.
15,5.
Yeah.
Okay, good. Well done, guys. This is the theorem of Pythagoras.
So we're allowed to leave